Hello everybody, welcome to this next lecture segment. This again is a hugely important chapter, and I want to make sure, and it's also very content rich. I want to make sure you understand where we're going. The first lecture segment was really reactions that involve that. That's all that it was following the H plus and sorting out the reactions. The next thing we're going to do is go back and do stoichiometry. This is really what we did in chapter 6, except we have acid-base reactions and we have solutions. So that's chapter 9. Very short. We'll do some stoichiometry. I think they're really fun. They're often long, drawn-out problems. And then the next segment will be we'll be talking about acids and base, basically in water. Okay, with that, so you have a little bit of a roadmap of where we've been, what we're doing next. I'm going to, and you've watched the video on titrations. You saw basically a titration is solution stoichiometry with very precise volume measurements. So we'll say solution stoichiometry with precise volume measurements. Now, previously in chapter 6, we often would weigh something out to get the moles. Well, now we know moles per liter, and so we're measuring the volume to get moles. And the end point that you saw in that video is basically when all the acid and all the base have reacted. It's a little bit more complicated than that, but that's reasonable for us. So we'll say all acid and base is basically consumed. And so this is a little bit of a fib, but it's okay for Chem 51. We'll say, well, it's neutralized. Now we can go back to chapter 6. Here's a problem. Basically it says, I have an old bottle of HCl and I can't read the label. And I've got the concentration of the sodium hydroxide. Let's see, I'll make sure it's clear. This is sodium hydroxide. And I'm going to take a 20 milliliter sample of the acid. So what I want to do is figure out that volume concentration of sodium hydroxide. All I have to do is say, well, can I convert that into moles? If I know that and I know the mole ratio from the reaction, I can then convert that to moles of HCl. I've got the moles of HCl, the volume of HCl, and I can calculate molarity. Now, let's see. I've always got to have a balanced chemical equation. Oftentimes, it's just 1-to-1. But if I say NaOH plus HCl, 20 milliliters of that, 58.4 milliliters of that, and I go, oh, well, that's one of the reactions we already looked at. I know I'm going to get NaCl and water. So all my mole ratios here are 1-to-1. It isn't always that way, but in this case it is. Now, these problems get really drawn out. So I've changed my format today. This is problem 10.29. So I want to know moles of HCl per liter of HCl solution. That's what I'm trying to get to. And I've got a number of things I know. Like all these unit analysis problems, there's 10 different ways to do this. But I might start off with, I know I've got to get to moles of HCl. I somehow need to go from moles of NaOH. So I'm going to do this, 0.250 moles NaOH per liter of NaOH solution. Well, I'd like to cancel liters of sodium hydroxide solution. I don't have liters of sodium hydroxide solution, but I do have 58.4 milliliters of the NaOH solution. Now, one of the tricks with these stoichiometry problems is keeping track of, well, that's liters of the sodium hydroxide solution. You're going to have two solutions, so it gets tricky to keep track of them both. I go, well, I could make the liters and milliliters cancel. That would give me liters, liters, milliliters, milliliters. If I do this, and then I could do 1 mole HCl, 1 mole NaOH, moles of NaOH have canceled. And I'm going to stop here because I'm just running out of paper. I get 0.0146 moles of HCl. So it's like I've got that part. And if you look back at the problem, it said that was a 20 milliliter solution of HCl. So I could say, okay, 0.0146 moles HCl, 20.0 milliliters. Well, there's moles over volume. To get molarity, I need moles over liters. 1 milliliter, 10 to the minus 3. And if my math is correct, I get 0.730 moles HCl per liter of HCl solution, or the shorthand, 0.730 molarity HCl. Now, again, there's a number of ways I could have done this. I could have started several different places, but that'll get there. The beauty is, of course, just like in chapter 1, if I get something wrong, eventually I'll realize, oh, wait a minute, I can't get moles of HCl on top, liters of HCl solution on the bottom. Usually it just means I need to go somewhere, flip something over, and restart. Now I'm going to leave 10.30 because this is going to be a long lecture segment anyway. The answer to that is in the back of your book. Give that a try. If that doesn't make sense, email me, text me. I'm surprised that texting office hours works really, really well. Okay, let's go to the next page. Look at another sample. Now 10.31 walks us through this, breaks the steps down a little bit finer, I think. So I've got 21.5 milliliters of base, 16.1 milliliters of 0.150 molarity H2SO4 solution. So this one says, okay, let's stop and say how many moles of H2SO4 were used. So I could go 0.150 moles H2SO4 over liters of H2SO4 solution. And I started with that because I know I wanted to get to moles. Well, that's got moles right there in it. 16.1 milliliters. Let's see, volume. Then I can make the correction, make the unit conversion, liter, 1 milliliter, 10 to the minus 3 liters. And of course, there's more than one way to do that. Many students will write 1 liter, 1,000 milliliters. That's fine as well. I get 0.0242 moles H2SO4. I'm going to do that. Now, molarity of KOH, I need to get to moles potassium hydroxide per liter of KOH solution. Well, I've already been given the volume of the KOH solution. That'll have to be converted to liters, but that's no big deal. Well, how am I going to go from moles H2SO4 to moles of KOH? Well, I have to think about the balanced chemical reaction. H2SO4 plus KOH equals. And now, of course, we think, oh, well, this is really a couple of H pluses. This part that we're interested in is really OH minus. And I know I'm going to get water and an ionic compound. Well, that's got 2 H pluses. This has 1 OH. So it's probably going to be 2 to 1, 2. And I'm not going to worry about balancing the rest because that's the only part I need. So now I'm going to go 0.0242 moles H2SO4 2 moles potassium hydroxide, 1 mole H2SO4, I'm going to put the 21.5 milliliters on the bottom, do a milliliter liter conversion, 1, 10 to the minus 3. And when I did this math, I got, it looks funny to me. I'm going to double check my math. Yes, I do have a dumb math error. I'm going to correct that right now. This should have one extra zero, so 0.00242 moles, 0.00242 moles H2SO4. And when I do this math, now that you don't trust my math, of course, understandably, 0.225 molarity KOH. This last acid-base stoichiometry problem, I'm going to help you get it set up a little bit. The answer to this one's in the back of the book. The reaction is basically this. There's my acid. And of course, we recognize this now as the base. Plus NaOH gives me water. And the leftover sodium ion. That's we got 2 of those. Everything else is 1 to 1 to 1. But the ratio of the acid to the base is 1 to 1. So I've got 50 milliliters of the acid rain solution, 9.30 milliliters of the sodium hydroxide solution, and I know its concentration, not very concentrated. So what I'm trying to get to, of course, is, you'll remember that brackets around the H3O plus, that means molarity, moles H3O plus per liter of its rainwater solution. That's what we're trying to get to. So the path is going to be something like, use this to get moles of sodium hydroxide. From moles of sodium hydroxide, you can go to moles of H3O plus. It's 1 to 1. I can convert that into liters. So that's going to go there. I'm going to use that to calculate moles of NaOH, and that's going to go there. The answer's in the back of the book, so if you don't get the right answer, you don't get the same answer, text me, email me, and we'll go over it. Okay, that's long, drawn-out math puzzles that, of course, I love to do, but you'll need lots of paper for these. Okay, the next idea, we're going to leave this behind and say, what if we just throw acids and bases in water? What do they do in water? That's the next idea. The fancy name for that is Arrhenius acid and base definition. I'll see you then.